All right, so talking into the next chapter, chapter 14, let's compare the Aristotelian view of the universe to our modern Newtonian view of the universe. Okay, so Aristotle thinks of the universe in terms of the heavens are made of the fifth element, the heavens are unchanging, stars are on a sphere, everything circles around the earth. Okay, in that sort of universe, that kind of universe can be infinitely old. The fifth element never changes. Okay, so it's eternal. Things move in circular paths continuously. Well, circles don't have a beginning and they don't have an end, so something can circle indefinitely. If you were if you believed the Aristotelian universe, you could believe the universe was infinitely old. You could also go and believe that the universe was created like that by God 6,000 years ago. That Aristotelian universe works with either view, Aristotle or Usher. Okay. Isaac Newton comes along, of course, and under the Newtonian view, which we've studied Newton's ideas, everything in the universe is made out of matter, like the earth. Okay, so there is no fifth element. The heavens can change. Things in the heavens are subjected to the same laws as things on earth, so gravity and momentum work on earth, and gravity and momentum work out in the universe as well. And so stars aren't lights on some big sphere out there. Okay, stars are sun-like bodies distributed throughout space. Well, if stars are suns, here and here and here and here and here, and they are subjected to Newtonian physics, that means they have mass, therefore there's a gravitational attraction between them. And so they're going to pull toward each other. Now, they might not pull toward each other very much, but it doesn't matter. No matter how slow, you can imagine them pulling toward each other. If the universe is infinitely old, they will have had time to come together because they would have had an infinite amount of time. So in a Newtonian universe, all these stars out here have gravitational pull between them, and that wants to make them collapse toward one another. Given enough time, no matter how weak the pull is, they will eventually collapse in on themselves, and in an infinitely old universe, they would have done it an infinite long time ago. So the universe could not exist. A Newtonian universe can't be infinitely old, basically, is one way of looking at it. Isaac Newton viewed the universe as being created by Lord God, the Pantocrator, in his view, the ruler of all, is how he called it. And he believed the Pantocrator had spaced the stars out widely so that collapse was not a problem. I presume at least he meant that in a limited time, in 6,000 years. Newton was a Christian, sort of. He had very unorthodox ideas about religion. He spent a lot of time studying the Bible, but a lot of his ideas probably would have been considered not really acceptable by the established Church of England at the time. So Newton recognized the collapse problem. Another possible way to get around the collapse problem was to say, well, the universe is also infinitely large. Okay, so if the universe is infinitely large, and you have a star here and you have a star here, and you say, well, these pull together, because of Newton. Well, but if the universe is infinitely large, and there's another star here, and another star here, and another star here, and another star here, and so any given star is being pulled by equal number of stars in any particular direction that you want. So that no matter where you are in the universe, there's an infinite number of stars in that direction, an infinite number of stars in that direction, infinite number of stars that way, infinite number of stars that way, and so all the poles cancel out, and so that should get you around the collapse problem. Well, the problem with this is that if the universe is infinitely large, then when you look up at the sky, you should see an infinite number of stars. Even though some of them would be, of course, exceedingly far away, there would be vast numbers of them. And essentially, no matter where you looked up at the night sky, you should see a star. And so the sky should be just a fog of stars, like the Milky Way. Okay, you say, well, Well, if the stars were really small, far away, wouldn't they be too small? No. Okay, we can do the math of this, and it doesn't and show it. But it's a more simple way of just thinking of it is to think of a literal fog. Fog consists of droplets of water. Those droplets are tiny. Okay, when you're in fog, you can see your hand fine if it's right in front of you. There's droplets between you and your hand. There's not that many of them. But as you go, if something's further and further away from you, there's more and more droplets. And even though you can't see each individual one, the combined total of all those tiny droplets, even at a pretty far distance away, is enough to block out whatever it is that you might be trying to see in the distance. So that just the fact that they're far away and little does not mean that they don't have an effect on your vision. And that's the way it would be with the stars. This was called Olber's paradox by Heinrich Olbers, who was from Bremen, Germany. And Olbers recognized this problem, that the universe, if the universe was infinitely old and infinitely large, then the sky would be a fog of stars. So the universe can't be both infinitely old and infinitely large. Now, if the universe was infinitely old but not infinitely large, then you have the collapse problem that we just mentioned. And so that means essentially the universe cannot be infinitely old. Okay, the universe has to have a birthday, okay, a start point. That way, first of all, if the universe is limited in size, then you would just say, well, there hasn't been enough time for the collapse to occur. That's kind of what Newton was getting at, I think. And the other thing is, you could say the universe is infinitely large, but if it has a beginning, so if if Newton was right about the Pantocrator, the Lord God zapping the entire universe into existence, and it's infinitely large, well, there won't have been time for the light from the more distant stars to reach us yet, and so therefore we can only see a very small portion of the universe, and so we still have a dark night sky. So the bottom line is this Olber's paradox, the problem of the dark sky and the fog of stars, suggests to us that is a piece of scientific evidence to suggest that the universe must have a limited age. Okay, so Aristotle cannot be right about an infinitely old universe.